Okay, let's do more. Feel free to, pause the video at any point. And just do this on your own and check back at the end to see your answers. But just keep in mind this matching type is tricky. This isn't stuff that shows up on a test, right? I'm not going to give you a giant matching page. Neither is the AP test going to give you that. But it's good practice and kind of understanding. So, couple things. All right, so we have a pipeline company. The pipe sells for $100 per meter. The cost of manufacturing varies with its distance from the beginning of the pipe. Of course it does. The company reports that the cost, that is X meters from the beginning of the pipe, C of X dollars per meter. And profit is difference between the amount of money received and the amount of cost. So here's kind of what we know. So if C of X is cost per meter, dollars per meter. The integral of that cost per meter is going to be the accumulated cost or the total cost. You can accumulate anything in terms of integrals here. Accumulated or total cost, because that's the integral of a rate. If you took the derivative of the cost per meter, that's going to be either the cost per meter, kind of like a weird acceleration unit, or the rate of change of the cost per meter. So now we go through and match. And again, you could start with the letters. I'm just going to start with the numbers. So if I look at number 1, this is the integral from 0 to 125 of cost per meter. So it's going to be accumulation. So it's going to be like a total cost. So it looks like it's going to be B. If we look at number 2, let's see, 1 over 125, and the limits are 0 to 125. That looks like an average, right? An average value. So what is this value we're finding the average of? Well, it's going to be profit, right? Because it's going to be $100. So if we integrate that, we'll get the amount of sales, or the amount of money you receive. If you integrate C of X, you get cost. So that's going to be the average profit. So C. Number 3, that's another average. Here what we need to do, actually, this is sort of a typo here. Get rid of that 100 minus. But if you integrate the rate of change and multiply by 1 over 125, this is going to give you the average rate of change in the cost per meter. So that'll be E. Number 4, we're integrating cost. We're going from 50 to 100. And so that looks like it'll give us the difference in cost, right? So it's kind of accumulated cost, but it really is accumulated cost between 50 and 100, which is going to give you the difference in cost. If we look at number 5, 1 over 50, this is going to be some sort of average. What other average do we see? Well, it looks like G, and that should make sense because it's the average difference in cost per meter. So this will give us, if we ignore the 1 over 50, we get, if we ignore it for a minute, this is, again, the difference in cost like we just found for number 4 from 50 to 100, but average cost per meter, you multiply by 1/50th because there's 50 meters between 50 and 100. Number 6, this is just going to be sales price. So between, so it looks like difference in sales price, 50 and 100 meters of pipe. So that's going to be A, because sales price is $100 per meter from up above. And the last one's got to be F. Let's make sure it makes sense. Difference in profit between 50 meters and 100 meters. Yep, makes sense. 50, 100. Profit is going to be $100 is what money you make per meter, and then integrating the rate will give you your accumulated cost. Next one. Again, feel free to just stop the video, do it on your own. So let's see what we know here. A cup of boiling water. It's set on the counter to cool. Initial temperature is 100. Temperature of the water as a function of time is T of T. So we know that T of T is temperature in degrees Celsius. If we take the derivative, that's going to be rate of change of the temperature. Okay, so then looking at our matching, let's see. T prime of 4, that's going to be rate of change of the temperature at 4. Perfect. B. Number 2, looks like we're accumulating something because we're starting at 100, we're adding 0 to K. So if we integrate the rate of change, it looks like this is going to be the temperature at K. You see that? Yeah, we do. It's G. Number 3 looks like an average, 1/4. Limits are 0 to 4. The interval is 0 to 4. Looks like it's going to be the average temperature from 0 to 4 minutes. Good, that's C. Number 4, that's going to be the average rate of change, right? Because T prime of T is rate of change of the temperature, otherwise it looks the same as number 3. It's going to be F. Number 5, well, if we integrate a rate, we get accumulation. So this looks like it's going to be the change in temperature between 0 to 4, or the accumulated temperature change, however you want to look at it. So that's going to be D. It's how did the temperature change between 0 and 4, same thing as accumulation. Number 6, that's just going to be the temperature at 4 versus the rate of change like number 1. So that'll just be E. Number 7, well, let's see what we have left. An equation that can be solved to find K. An equation that could be solved to find average temperature. So number 8 is definitely average, right? Because we have 1 over K, 0 to K. So that's going to have to be H. Number 7, we have to look a little more deeply here, right? Let's see. An equation when the average temperature is 85. See, isn't this fun? I make little mistakes, just like real life. So let's see, let's look at A. Average K, the time in minutes when the average temperature is 85. So average temperature is not going to be the rate of change at all. It's just going to be 1 over K minus 0 times 0 to K, the integral of temperature. So number 8. Average temperature. So number 8 has got to be this is kind of tricky, right? Yeah, this is totally like real life. I'm really sorry. Actually, I'm not sorry because it's just like you're in class. Average temperature was 85 from 0 to K. These shouldn't both be average. That's the issue. I think we found a typo. Yep, so average, so number 8 should be H, because that makes sense. Average from 0 to K. Number 7, this should just be temperature. So an equation that can be used to find K when the temperature is 85. That makes sense because we started with 100. Whatever temperature change we had from 0 to K equaled 85. So if we get rid of average, number 7 is A. Sorry about that. All right. Just keeps going. All right, so for this one, let's see, how long is this video so far? 10 minutes. All right, I'll keep it going. I might as well do the last one for you too. However many of you are actually listening to this part, which is, I can think of a few of you that will. All right, so we're back to the example that we did on an earlier page talking about, you know, people waiting in line to buy tickets. And so we have people moving out of the line, like selling them tickets, that's S of t people per hour, and then more people are joining the line at L of t, which I think is kind of weird because like L of t seems like it'd be like leaving the line, but that's okay. I guess S of t is selling and L of t is line, but that's cool. So let's see, if we look at number one, we're starting at 75. That makes sense because at 3 p.m. there were 75 people. Integral from 3 to 5 of L of t is going to be how many people are joining the line. And so that's going to be C because this is just telling us the people that have stood in line. We're not dealing with people who have, you know, left the line and sold tickets. Number two, so from 3 hours to 5 hours, integral of S of t is going to be the amount of people moving out of the line who are getting tickets. So that'll be A. Number three, 75, and then we're looking at people joining the line and leaving the line. And so that's going to be the overall change that's happening, because in general we have 75 people. People are coming, people are leaving. So that's going to be, nope, not D, because it's going to give us actually our amount, right? Because 75 plus whatever happened from 3 to 5 p.m., that'll give us our number. Let's see, and then number four, that's just people entering the line, so that's E. Number five, that's going to be the change in people because, you know, this is not including the 75 that started. What happened? Well, you know, people joined the line and people left. There's our accumulation, so that's D. For this one, I'm going to have you do this on your own. You can check the key. Thanks.